Hello and welcome to this week's video on breaking down the Azure network chains. This week we're going to talk about load balancers. I'm Dwayne Natwick. I am a senior cloud training architect, a Microsoft certified trainer, and a regional lead for that Microsoft training program. You can find me on the social media links provided on this slide. So we've covered a few topics to date on Azure networking. We started with virtual networks, and then we went into network security groups, and we talked about Azure firewalls. Today we're going to talk about load balancers. To review, we've talked about building our network security posture throughout all of these videos. And again, when we're talking about load balancers, we're again talking about perimeter security as well as network security, because load balancers have the ability to provide additional security capabilities both at the perimeter but also within the internal Azure environment. So what are load balancers? Load balancers are a transport layer protocol device at the layer 4 level, and they work on TCP and UDP protocols. They can be utilized for back end and endpoints for both internal and external connectivity, such as to Azure virtual machines, Azure virtual machine scale sets. Something that's not mentioned here is if you have SQL databases on virtual machine instances, you can take traffic and balance traffic between those devices, which we'll talk about a little bit more in a minute. SLAs for a load balancer are at 99.99%. So Microsoft is guaranteeing availability at this level for load balancers that you stand up in your environment, and they'll provide service credits if they do not meet those SLAs. There are two SKUs for load balancers within Azure. There's the basic SKU and the standard SKU. For many of your requirements, the basic SKU will meet your needs. It is a zero charge service within Azure. So again, similar to VNets and NSGs, you're not paying for this service. So you can build and continue to build your perimeter security and your network security with a load balancer in your environment without incurring any charges besides the network traffic charges that are incurred for egress within the Azure environment. So anybody entering your network and hitting a load balancer is not going to be a charge for you. The standard SKU provides a little bit more functionality, where a basic SKU can only do one set of routing. It's going to take that traffic that's going into the load balancer, and it's going to route that traffic in one set of backend pools. The standard SKU has the ability to create rules and move that traffic based on what that traffic is and what that rule is, what port it's coming in on, and the like that, and take that to different backends rather than just one set of backends. So it provides a little bit more flexibility from that standpoint in your directing of traffic and customizing how traffic is directed within your environment, whether it's internal, intranet traffic from your organization, or it's internet traffic for customers reaching your website. You could use that standard SKU load balancer to move traffic around within your environment. There is a cost, though, that goes along with that. It's based a lot on how many rules you're creating and the amount of traffic that's being routed within that environment. So keep that in mind when you're looking at architecting with the standard SKU. Like I said, you could create multiple load balancers on the basic SKU to route traffic if you have the external connections available to do so and have the capability to do that. Or maybe everything's hitting a firewall, as we'll show in a moment when I kind of break down and we start looking at architecting the network. If everything's coming in and packets are being evaluated by a firewall in front of the load balancer, then it could go to a multiple basic load balancers and take that traffic and move it accordingly using the firewall rules to to do that routing. So different options that you have within the Azure environment for routing traffic that's coming into your network. So as I stated, there are also external and internal load balancers. And just to give you an idea to understand what the difference is between the two, from a routing capability, there isn't really any difference. It takes the traffic and routes that traffic to the endpoint that it is configured to route that traffic to, and it's going to balance that amongst the set of endpoints that you've identified. The load balancer, when it's external, is going to take the internet traffic and route that internet traffic. An internal load balancer is utilized for traffic inside of your network. So if you look at this diagram here, you have a set of web tier virtual machines. So traffic is coming in on port 80, so standard HTTP internet traffic. It's hitting that public load balancer and it's going to your virtual machines. For an internal load balancer, that may be going then to a business tier, such as maybe your CRM system, and it is going to those virtual machines and it's balancing that traffic again on that end as well. We'll show another example here in a moment also. The benefit from a security standpoint here, as we're talking about load balancers, is that for internet traffic, the load balancer is the only public IP address that's exposed in your network in this case. The virtual machines, you can remove public IP addressing and protect the exposure of that virtual machine and decrease your attack surface that can be found by scanning IP addresses, scanning public IPs for a attacker that's trying to get into your network. So, and a load balancer, unlike a virtual machine that's running an operating system, doesn't have much of an attack surface. It's more or less a dumb routing machine where it's just looking at ports and it's routing traffic to the back end. It is not something that an attacker can gain access to and find out information about those back ends. So it's very secure from that standpoint in protecting your network. So let's review where we are up to this point in building and breaking down our networking chains. We've talked about, and we started with our virtual networks, our VNets, which are up at the top here. And you can see in this diagram, I've built 5 different VNets within my architecture. I've architected and isolated every component within my network, and we can then peer those, as if you recall, to be able to communicate in between those VNets. Within those VNets, we have our NSGs that provide additional routing rules and allow and deny rules within our network in what's going to be allowed. But we're allowing that VNet to VNet peering, and we also have load balancer rules already built in. If you recall, or if you want to review from the video on NSGs, having load balancers within our network are a default rule to allow that traffic from a load balancer in our network. So we don't have to do any additional configuration when we put a load balancer on our network on our NSG rules, because it's already there. We have our firewall that is our perimeter device. We have our firewall, which is our perimeter device that's taking traffic. It's doing that deep packet inspection, and it's pushing traffic to our load balancer. And then our load balancer is then directing that internet traffic to our virtual machine endpoints. And in this example, I'm showing both a single virtual machine as well as a virtual machine scale set, which allows to balance that traffic amongst our high availability and scalability of our environment. The load balancer, which I didn't mention before, has a health probe that is built into it that periodically checks on a regular basis the health of the virtual machines that are there, that are the back end endpoints that it's going to route traffic to make sure that it's online. So if you have automatic shutdown on one of these virtual machines and that shuts down, the health probe is going going to see that it is not online, and it will route to the ones that are online. We could break this chain apart and take a firewall out completely and direct traffic directly into this load balancer. We do not have to have a firewall in our environment, but of course, for anybody that has architected a network, and anybody that, if you're not a architect or a security person, if you're talking to your security group, they're going to want to have a firewall in place. So this is definitely a best practice architecture in this case. We can see at the back end here is we have another load balancer that's an internal load balancer that these virtual machines might be accessing. In the previous example, it was showing it was accessing a internal set of virtual machines. We could also think of it as we're accessing a database as well. So somebody's coming into our network for our web application, and we are going from there, and we need to access our databases for inventory and take that and present that to users. And we can protect and isolate our databases and the attack surface on that those databases by having another layer of load balancer protecting the IP schemas and the network interface cards of those SQL databases. So let's jump into the portal here. So let's take a look at how to configure our load balancer. So we're in our Azure portal, and we're going to just go in here and we're going to type load balancer, and we're going to find our load balancers, and we're going to create a load balancer. And much like many of the services within Azure, we need to give it a resource group and a name. All this LB1, got it in East US. And here we can say whether it's internal or public. Again, we have our basic and our standard SKUs, and we can learn more about here. Here's one thing with standard load balancer, we have up to 1,000 instances. We have greater backend pool flexibility, as I said, HA ports, and some zone redundant scenarios in here. So there's some additional information here that you can gather around your choosing of the different SKUs. But we're just going to go with the basic. We need to create a public IP address for the load balancer, and we'll assign it as dynamic, and we're going to review and create. So in a moment, our load balancer will be set up. Now, our load balancer isn't ready to go yet once we set this up. We need to do some additional configuration once we've created our load balancer that isn't part of the Azure portal. If we're using Azure PowerShell or running Azure PowerShell for our creation of our resources, we could put this additional configuration into our PowerShell scripts before we run them. But here, load balancer doesn't take long to do that. And you can see we get our step-by-step tutorial right as we go into our resource. And this is really what we need to do here is we need to get our front end configuration done. We need to get our health probes enabled, and we need to secure our networks. And here backend pools is another piece that we need to take care of. So we have nothing in our backend pool. So we are not right now directing traffic anywhere. So we need to definitely do that right off the bat. So we need to create our backend pool, and we're going to put it on our VNet. We're associating it to virtual machines, and I made a mistake here where my virtual machines are. So I can add this to the virtual machines. I don't have any virtual machines right now. Let's go back to our load balancer capabilities here. Let me double check here where my virtual machines lie. I think they might be in West US actually. VM in Central US and West US. So right now I could only route to one virtual machine at this time, but we'll do that real quick here. Create another load balancer, and I'll make sure I create it in Central US this time. One thing you need to understand when creating a load balancer, if you want to connect existing resources, that load balancer needs to be in the same region as the backend pool that you're going to utilize. So we're reviewing and creating. And again, once this load balancer goes, go to our resource, and here we can add our backend pool, create a virtual network, associate the virtual machines, and now we can see we have our virtual machine, and we can add that to our pool. And if we added additional virtual machines within our central US region, we can then create add those to that backend pool to route traffic as well. So we're attaching this virtual machine, and the virtual machines, again, you can see must be in the same availability set, and all configurations must be in the same virtual network. So if we go into health probes, now we need to also create this health probe for our load balancer to check the availability and health of our virtual machines. And you can see you can set the interval if you want to much larger than 5 seconds, and it's going to mark a resource unhealthy if it gets 2 consecutive failures. So if it's pinged twice within 10 seconds and it fails those times, it's going to be taken out of the queue for the load balancer. So we're going to update, and it's going to then create that health probe and begin to check our backend pool of resources for being online and being available to route traffic to. And as we notice, we had to do our front end configuration. We do have our front end configuration already here. That does create automatically. And we have our public IP address that we created when we created our load balancer. So nothing new that we have to do here unless we're going to change our public IP address or create a new one within here. So we're just validating our front end as we save, and we're good to go there. So that is really all that goes into creating our load balancer. And we can create, and you can see and view some additional inbound NAT rules if we want to, and can have our front end IP, give some idle timeouts, and create our virtual network in here in terms of, do we want this to only be port 443, or do we want to allow port 80? And we can go through and create a NAT rule for our load balancer as well. So now we're all set. We have our port 80 traffic all ready to go. And if anybody goes to our network over our public IP address, it's going to hit this traffic, this load balancer, and it's going to route our traffic to our virtual machine. And the one last thing I want to show after this finishes, the last thing I want to show here is just the information here. And you can see here is our public IP address that was created and given to our load balancer. So if we're routing traffic from our website, it should be that traffic that's entering our network for our website should be coming to our Azure environment using this public IP address. And my virtual machine right now actually has a public IP address on it. But what I need to do now that I have this load balancer in front of it is remove that public IP address from my virtual machine. And we won't go through that step today, but we can very easily through PowerShell run a update on our virtual machine to take that public IP address off, or just remove it within our virtual machine. And this ends our video on load balancers as part of our Breaking Down the Azure Networking Chains video series. I appreciate you tuning in, and you can reach me on the social media links provided on the slide. Thank you very much, and I will see you in our next video next week.